All right, welcome back to episode 3 of our live auditing series. In this particular series, we are auditing Key Finance, who's making GMX Key, which is a liquid version of escrowed GMX. And this is sort of a convex-like solution for locked GMX and GMX rewards. And what we're doing throughout this series is auditing their LP staking contract, which incentivizes liquidity providers to actually go ahead and make GMX Key liquid. So last time we finished up gathering context on the fundamental goals of the contract, and we covered every single function, and we sort of got our hands dirty, and we even started looking into some interesting leads and interesting things that we noticed right off the bat as we were doing our initial walkthrough. And then in this episode, we got into really the fun part of an audit, when you start to be able to just dive in and now you actually understand the system fully, and we're able to actually start trying to exploit things and find bugs in the system. All right, so my name is Owen, and over a year and a half ago, I founded Guardian Audits, and since then we've audited hundreds of smart contracts, and we've uncovered dozens and dozens of critical and high vulnerabilities. And my goal with all of these videos that I put out, and especially this series in particular, is to distill down everything I've learned along the way, take my auditing process, and give it directly to you so that you can ultimately become a much better smart contract auditor than I ever could be. All right, without further ado, let's dive right into episode 3 of our live audit series. All right, guys, so like I said, at this point, we already have a good amount of context on the system. We understand how each individual goal is accomplished in the system, and now it's time to really start to have fun and dig in and start to try to break things and find some little knobs that an attacker can turn to walk away with more money than they're supposed to, or potentially grief others, or make the system just end up in an unexpected state. So without saying anything more, we're just going to dive in and start pulling on some of those threads that we have already built up along the way as we were going through the context gaining process. And so first of all, since we last looked at the code base, they made some slight modifications. The most notable change is actually the on ERC 721 received in this function here. Previously, this was a stub function, and now they've moved the logic from deposit into this function. So quickly, let's have a look at the deposit logic. So we've got deposit and stake LP token. Okay, so now this is a loop where we're just grabbing the token ID, and really this doesn't even need to be stored. Doesn't even need to be stored on the stack. This could just be populated in here, and they're doing the safe transfer from, and then that will end up calling this logic on each of those iterations. So of course it's going to be only this NFT is accepted. And okay, I see, so they have this check here checking if it's not from the V3 staker, and that's important because if we are, let's see, I believe if we're, so when we collect fee, that's right, we withdraw the token, and then this one is going to send our position NFT back to our address, and we're going to end up triggering this. This is of course going to pass, but we're not going to go in here. And that's good because we don't want to be writing new mappings or anything like this. We don't need to be pushing again to this list, for example, or resetting the indices here. So that's good. Okay, and then this just allows users to transfer NFTs directly here, or other smart contract systems to potentially build on top of this staking interface. So immediately I'm actually interested and a little excited because you'll remember last time at the end of our last episode, we were looking into this potential reentrancy here, and we couldn't find one because we didn't have any knobs to turn in this particular contract. All of these are non-reentrant. we did start to enumerate the potential knobs in this Uniswap v3 staker contract that we could interact with directly. We couldn't quite come up with something for this and all of these, but now what they've done is they've actually given us another knob here with this small addition. So now we have a function that they don't have any sort of reentrancy guard or any protection against reentrancy inside of here. So we're going to play with it, and we're going to see if there's anything that we can do to get something unexpected. I'm thinking maybe there's a way for us to end up owning the token twice, or having two different people own the token in the system. That would be very unexpected. Or maybe we're able to get rewards twice somehow. So let's see. So we're interested in this function, because this is where the reentrancy stems from. So let's see. Really what we're getting out of this reentrancy is we know that all of these, so the ID to owner mapping, the staked index, and the staked list for the owner, that's what the tokens staked for the owner, we're going to be removing from that list. All of those storage variables are not going to be updated yet when we call this. And so if we're looking at that through the lens of being able to call this, we can essentially deposit something into the system. And okay, so that's interesting, and stake it, right? Because we're going to be transferring it to Uniswap. For the current incentive, we're going to be able to stake it for the current incentive. What does that get us? So let's see, let's just walk through it, right? So we withdraw the token. These are still, all of these still haven't been deleted at this time. Okay, we're going to pass this. We are going to pass this. The operator, it could be from, yeah, we can definitely make this true here. This is not going to be true, but okay, so we can make this true. From has to be the operator. That's interesting. Okay, so they're saying no operator can basically get approval from other users to then take their tokens and inject them into the system. That seems like a fine assumption. I don't really know off the top of my head what they're guarding against with that. But okay, all I know is on this reentrancy we can get past this. So let's see. Okay, sure. Yeah, we will have the minimum liquidity if we were able to get into the system in the first place. We could, before we actually do the re-entering, we could change the liquidity, but then, okay, we still have to be above this bound when we do re-enter into this contract. So let's see, we're going to register. So see the ID to token, the token staked, and the staked index. These are the things that have yet to be deleted. So ID to token, ID to owner, staked index, and then the other one, which is this is the thing that gets pushed to, right? So that's actually interesting. I'm going to circle back to that. And then what happens is we deposit and stake the token with the current incentive key. So it's like you just withdrew it from Uniswap, and then we are depositing it again and also staking it for the current incentive key, which that might be fine, because if you think about it, you could reduce that down to simply unstaking and withdrawing one, letting this complete, and then in a separate transaction, then basically depositing again and calling this effectively, and then depositing and staking. So I think that's fine. So the interesting bit is here, where we're going to write these storage variables before we actually end up deleting them. So is it going to be pointless to just write them because they're going to be deleted, right? Okay, so this is the token ID. This one's based on the token ID. This one's based on the from. And we can make the from different than what the previous owner is. That's interesting, actually. We might be able to get two people owning. Okay, we're not going to be able to get two people owning this because this mapping only it's from a token ID to an owner, a single owner. Only one person can only ever own a token ID. Then we're going to delete it, whatever it is, so nobody is going to own it. Nobody owns it. It's not going to be in the staked index. So no matter what values you set for these two mappings, they're going to be zeroed out right after for whatever you do here. Interesting one is this. So let's see, we get the token staked for the owner, which is the message sender, I assume. Yeah. Okay, so the message sender, the person who initially unstake and withdraw for the token ID. And it's, okay, so it's for the owner. I can get a different person to be owning this, right? When I do this from, we can have this from be disjoint from the original owner while still passing this. That's totally achievable. So we give the token ID to that person. It does have to be an address that we control. Yeah, I don't see a way we're going to force this into somebody, especially, yeah, exactly because of this. So I guess what this check is doing is actually making sure that we can't sort of force an NFT to be staked into the system for somebody, right? This is basically saying this must have been initiated by the actual owner. And because from is, yes, because from is ending up being the owner. Okay, so there's that. We can't force it for somebody else. There's got to be something more interesting that we can do though. Like if I can deposit, I deposit back into Uniswap. Let's see. Yeah, let's look at this on ERC 721 received. Okay, we do get the positions. This is what's used for the deposit. Interesting, the deposits for the token ID, the owner here is going to be the from. So we can create a new deposit, and we can do so for this incentive key. Yeah, it will end up being for the current incentive key. We'll stake the token. We stamp it with these values here, and then the stake exists. Again, yeah, I don't see the distinct difference when we're just talking about interacting with the Uniswap system. Yeah, I think this is fine. The only things that are going to be out of sync, like not in agreement, would be these, but okay, so we know these get reset back to 0, so those will be fine. And then we've already addressed, we've covered that. This, you can't really force this into somebody else's staked. Like what I'm thinking about is like a front end that would display the tokens that you have staked. If you could force this into somebody else's staked list and, you know, maybe get them to like see that they have an NFT there, there could be potentially, they have that position there. Yeah, and then potentially it could be some form of phishing attack. I don't know what they would come up with. But getting them to look into that NFT, or even just, you could do a bunch of these, transfer those to the owner, and then they'd see they have a bunch of positions. I don't know. But you could cause unexpected behavior on the smart contract level, which could bubble up to the front end level and affect user experience. But I don't see you forcing this for other people. It's also worth noting that I think the NFT is basically locked. Since this is deleted, now if you wanted to withdraw, there's no way, because this is address 0. I think, yeah, any NFT you send here is going to be locked. So what you could do, so you could put it into the same address, and then since they break here, they're doing the classic, take the, you know, the end thing, put it in this, and then pop off the end. But and then since they break here, in this if case, then I think that they're going to ultimately leave one behind if we put 2 in here. So when I go ahead and we're pushing here, so we could push twice. So at this point, it hasn't been removed from this list. So there's 2 in the list. Then we get the list. We loop through it. We remove 1. We remove the first one, and then it breaks. So there's 1 left in the list. That would just show up in this list. Let's check all the uses of this list. Maybe they can leverage this somehow. This is the token staked. So technically speaking, nobody owns this NFT in the system. It's locked, but it still is in this token staked list. So let's see what we can do. Okay, so the number, okay, so we're gonna have to see where that function is used. That could be bad because we're gonna show a number of tokens staked that is higher than what we're actually owning in the system. I suppose that token it is really there, and it is staked in Uniswap, but it doesn't agree with the other mappings. And so we'll have to see if that disagreement can turn into something. So let's see. Get the number of tokens staked, and then just this other view function, we'll have to check that. Of course, where we push to it and we delete. Okay, so it seems like this is actually, okay, only directly used in these functions. Where are these called? This one is, okay, it's literally just a view function used by the front end. I guess, is this one? Yeah, this one is the same. Okay, so it seems like the impact here is really limited to any sort of front end manipulation, anybody calling these view functions. And I guess it's technically true that, these aren't technically lying, because again, this token is here, owned by this LP staker, and it is staked in Uniswap. However, if they do go and try to withdraw it, then of course it is lost. Yeah, I don't see too much coming out of that, because I think it would be a really interesting finding if you could force it upon other people. But I'm not even seeing a way to do that because, let's see, because the operator has to be the from. Okay, I mean, even if we didn't have this check, I don't think you could force it for anybody. Yeah, I don't think that check actually stipulates that in this case. Yeah, what we're saying with operator equals from is just that the person who actually owns the NFT has to be making this transfer. And so they're just disallowing any approvees from doing this, right? But in this case, the owner literally has to be the person perpetrating the reentrancy, because the owner of the original token ID here has to be the message sender. So I don't actually see anything too bad. Maybe it's probably worth a medium, just because it does put the contract in an unexpected state, and there's some disagreement in these mappings here, and there might be second order consequences of that we don't know yet, because we might not see other contract systems that are built on top of this. Certainly any contract system built on top of this would want to know about that risk, because that could potentially lead to a more critical exploit for anything building on top of this. And then also you have the front end weirdness where you're reading from these view functions and you read the token staked and it says that the owner owns this many, but then when you actually go to claim that, the owner's not going to be able to claim that. So I think this is worth a medium. Unfortunately, I'm not seeing a way to get anything higher out of this ERC 721 reentrancy here. There's the interesting aspect where it's like, okay, there are more tokens in this list. But of course, the thing is, for any subsequent iteration, it would be effectively the same as just calling this function once, unstaking, withdrawing one of these, and then being able to execute any arbitrary code, whether you do that here or you do that after the loop ends and the function call ends. I don't see there being a difference, besides, of course, this event and these storage variables. These only pertain to this iteration, this token ID. And then I believe we were briefly talking about a token ID being provided multiple times in the same list. I'm also not certain. I think that's also effectively the same as simply unstaking withdrawing. You could just call this function multiple times. You could have a multi-call. You could have a contract that calls it multiple times. You could just have multiple transactions recorded in the same block. Calling that, subsequently in a row. I don't think that's any different if we were able to get multiple token IDs. But of course, I don't even think we're able to do that because of this check here. Yeah. And then of course, if they were to use check effects interactions, you would move this up, right? So you would put this here. And then actually it becomes slightly interesting because then I see an opportunity for you to withdraw the token here. And then now you can re-enter, put it back in. And now since these mappings aren't getting removed, now you can pass this check. But again, that's roughly the same as just unstake and withdraw once and then deposit back into the system. It's all kosher, and then you could just continually do that. It's the same thing as doing this and just re-entering and putting it back in, because you're doing this at the end of the iteration. And I mean, to be completely check-effects interactions, really, I guess technically you should do all of the state accounting. I guess it doesn't matter, but you would do all of the state accounting in a loop. And of course, this is not as gas efficient as this, so you really shouldn't do this, but an idea is to do all of this accounting first in a loop and then do the interactions in a loop. But then, of course, you know, you could just multi-call, and then that would be effectively like the version of this, like this. But yeah, I don't see any issues either way. This should certainly be moved up. This should be moved up along with the event as well. Yep. And then, I mean, if they wanted to add additional security, even though I'm not seeing anything completely wrong with it, you would want to add some sort of non-reentrant check to this function. But that's that. So let's see. Now what I want to look through is, so we basically crossed that off the list. That's going to probably end up as a medium. That's how I'm seeing it right now. Unfortunately, we can't find anything else significant about this here. So literally what I'm going to do now is look through my audit tags, and we're going to see if anything's interesting here. And we've got this. Yeah, so what I'm really interested in now is this one's calling out to me right now. The fact that anybody can call this unstaked tokens. There's nothing here. I think in the past, I think we said, okay, it's fine if you unstake for a past incentive key because all of the incentives have been emitted, and presumably, yeah, it's been ended even if the incentives weren't emitted. So there's no harm in unstaking, because when you unstake, it's actually helpful. So if I was going to unstake for you, let's pretend you had a deposit, you had earned some rewards. Let's say I was going to unstake for you. I was going to unstake for you. We end up, I'm going to jump right to this. So we end up unstaking token for key. We get your staked index. And then, okay, this is again where we're doing the iteration. And then, okay, we have this little edge case. The first here could be something that the staker didn't explicitly stake for. We'll keep that in mind. Okay, then we see liquidity for these stakes. Okay, so if the stake exists, then we're going to unstake and claim reward. And then we increment the reward. And let's see this. Okay, so the reward, it applies to the token ID. And then I assume, I'm forgetting. So when we claim all reward, I assume you access the reward by, okay, so you have to check. Okay, so you do it for a token ID, and then you get the reward for that token ID in the message. Okay. Okay, so the reward for your token ID, right? Okay, so we incremented that. So I'm helping you by incrementing. When I call unstake, I call unstake for you for a past incentive key period. I'm really just incrementing this. I am pushing your staked index forward. I can push your staked index forward. I'm interested if we can, yeah, that's actually interesting. Let's see how it would hurt you. You could cause something maybe slightly unexpected if I observed somebody in the mempool send a transaction to the mempool saying that they want to unstake tokens, then I could front run it and, like, let's say, oh, you know this, okay, you're going to specify a key count. I can make you unstake for more than you wanted to, but I guess we're saying that's fine. Because, okay, so you specify a key count. Let's say I only wanted to unstake for 3, and I wanted to unstake for like 3 very particular incentive keys. I could front run you and provide 1, let's say key count of 1. Now I'm going to make you unstake for, a shifted triple of 3 incentive keys. So let's see. Then the exclusive last, that's going to be fine. The key count, waiting for the key count to come in, comes in this function. Okay, so it's just this if statement. This is where this is not going to be the max. And the range, if the range is not, okay, so if the range is not restricting it, then yeah, so here's where I could potentially get you to do more than you wanted. However, since the function is external anyways, does it even matter? I guess you should just always assume that stuff is going to get unstaked. And then we unstake token for key. Yeah. What if you were doing a different kind of unstake though? So in this unstake, I want to see if I can get you to unstake for the current incentive key, even though you didn't want to. So let's see. Okay, so you can only ever unstake for past incentives with this one. This one is interesting. Aha. This might be something. This might be something. We'll have to actually also look at these. That could be interesting. But, okay, unstake token once. If I see, okay, you provided token ID. Can anybody call this one as well? So I can unstake anybody from the current index? Let's see. I would assume you're not able to do that because you'd cut somebody's reward short. So let's see. Staked index, first index. If the first, okay, so here we're not allowing, yeah, we literally won't allow, we require it to be less than the first index. Okay, so then I'm interested, how do you unstake for the current? Right, is it only in this? Yeah, this is the only place where it's the max. Yeah, and those are internals. Let's look at these extend functions. Anyone can extend. We're going to stake for the current key. What if it's already staked? That's interesting. We're going to look into if it's already staked. I assume it would revert here. Let's look here on the stake token. I want to see the top level function. Okay, we're going to pass this because we're interacting with this through the LP staker. Right, it has to be a current key, and what we're talking about is, yeah, if it's already staked. If it's already staked, that's what we're talking about. If we restake it, total reward, so there has to be, okay, token already staked. Yeah, so it reverts right here. That would be pretty bad if this wasn't here. What we could do is re-stamp the position with this, and I assume that would actually be setting the rewards back to 0, because when we calculate rewards, let's have a look at the reward calculation. Where is that? Claim reward. So this has got to be, oh, that's from rewards. So we need to look at not the claim reward, unstake. Okay, unstake token. Let's see, it looks like everything's in here. There's no internal. Oh, that's right. We do have this. I do want to look into this. I think that I think this is actually going to be an issue, but we'll get to that in a second. I think that the fact that other people can claim, and that's going to be outside of the, yeah, I think that's going to be an issue. We're going to come back to that. That's the next thread we're going to look into. But right now, I want to look at, okay, so we get the, so if we were able to do that, I just want to understand. Okay, so we get the existing. Yeah, and it's this thing, which is what we set. That's what's used. We get that. And then when we compute the reward amount, okay, let's see. Yeah, it's based on, where does that one come from? Okay, so this is the current snapshot of the pool compared to when the position was stamped. And then we're getting the difference, right? And then this liquidity, that's going to be for the position. Yep. And then we're doing some left bit shifting. That's where we're getting the X128 minus the total seconds claimed. Oh, so total seconds claimed is a function of this seconds per liquidity. Okay, that actually makes sense. So we get the difference of what it is currently versus what it was stamped with. Side note, this makes me wonder if I could manipulate this value when, like, I'll have to look, well, I guess we'll want to investigate more how this value comes from. Maybe there's a way to manipulate this, and that would be an issue with Uniswap itself. Either like adding more liquidity to the pool or something like this. I'll have to look into how this is calculated, but we'll move past that for now. For now, I would add just, can this be manipulated by increasing / decreasing liquidity in a certain range for this. And then maybe there would be like some sort of sandwich attack or something like this. If you could at least reduce rewards, if you could make this difference smaller. Yeah, but I don't know how this is calculated right now. Okay, so you get the reward here. Okay, so that's returned. That's the reward. And okay, so we increment these things, we update the actual incentive, and then we set the rewards for the, oh, this is not the NFT, this is not the position, this is the, whatever the reward token is, right? So if the incentive program is shooting off DAI, that's what this is. And then it goes to the owner. What's the owner on the deposit? Isn't that the, I think that might be, that doesn't make sense. So the owner, because if you're incrementing the rewards, like, okay, so the way we pull rewards is we claim rewards. It's got to be the message sender, right? The address that always is the message sender when we're claiming rewards in the system is the LP staker, right? If we go to claim rewards, let's see. Yeah, we call claim reward for the reward token, address this. That's the 2. Yeah, where's the differentiation between, like, I assume, so you take your NFT, you stake it for a period of a certain amount of incentive keys, and then, yeah, and then you get those rewards, right? That's how this ought to work, because the reward gets incremented for the token ID over here, but when you get the rewards, when you claim the rewards, it's just in the mapping for the message sender. There's no token ID here, right? This reward token, that is not the rewardee. 2 is also the LP staker. And then amount requesters, of course, yeah. I think, so wait a second. When we unstake, that's when we increment these. Yeah, it's the deposit.owner. And when we deposit on ERC 721 received, oh, deposits for the token ID, but is it deposits? Okay, we need to go back to the, what do we need to go to? Got myself lost. Claim rewards. We need to go to claim rewards. Now I want to go to unstake. Unstake, there is no, okay, unstake token. Deposits, so the rewards deposit.owner. Okay, where's this deposit? Do we pull it into memory? Okay. It's from deposits, so it's the deposit.owner. What's stored there? Yeah, I assume that's the LP staker. So if we go to on ERC 721 received, the deposit corresponds to the token ID. That's right. The deposit corresponds to the token ID, and then the owner is from. That's right. Okay, so then on the deposit, when we unstake for the deposit, what gets written here? Yeah, you unstake for the deposit, but it's not like the rewards are incremented on the deposit. They're incremented for the deposit.owner. The deposit.owner is the LP staker contract. And of course, that's going to be the same for every one of these NFTs. That's the same deposit.owner. So all of these are getting accumulated for the same LP staker. The issue is that when we claim reward, we're accessing that one, there's only one slot in the 2D mapping here that holds this reward for everybody. So there's no way to separate out whose reward is which. Sure, the deposit here, this accounts for, of course, a single token ID deposit, but ultimately all of the rewards, so the reward that's calculated here for that single deposit, it gets thrown in this bucket for the owner. And so all of these are going to get thrown together when you unstake. And okay, so I think that would be fine. Maybe this is fine. As soon as you put something here, you need to take it away. You need to always claim. You need to always claim immediately as soon as you unstake. So here, let's see. As soon as you unstake, that makes me confused about this check. Okay. Yes, they may be safe. The liquidity here, so you see if it is staked, and then if it is staked, then that's the only case where you do unstake. I want to check, this better be the only place that they call unstaked token from the Uniswap v3 staker, and it is. And then, okay, let's have a look at claim reward again. Yes, so if you always, so unstake, we know here, this has gotta be the only place. Oh, but here's the thing is, there's also places where you withdraw. Right? Several places where you withdraw, so let's see. Sure, here we just unstake, but if you unstake and withdraw, there you unstake. Yeah, because you always have to unstake before you withdraw. Let's look at the fee collection. They withdraw here, but they unstake first. So every time you unstake, you're going to correctly account for these rewards. So then the question becomes, yeah, and anytime, so anybody can call these functions up here. Anybody can unstake, but then of course they're going to increment your rewards for you. I wonder if there's any way to get rewards in that mapping without immediately claiming them. And in the mapping specifically for the LP staker. So within this system we know every time you unstake, no matter what it's for, when you unstake from the system, and they always do this before withdrawing. Let me just check that. So if they withdraw, well, fundamentally speaking, they must always do this before they withdraw, because Uniswap won't let you withdraw without unstaking from every incentive key. Okay, so we can confidently say within this contract, every time you unstake, you immediately claim rewards, which means that this single bucket accounting might actually work, because there is that instantaneous moment where the bucket has value and then it immediately is zeroed out right afterwards. But that's within this system. The thing that we wanted to look at, this next thread, was, of course, somebody staking outside of, or unstaking, without having to go through the LP staker, because there's this edge case. If the block dot timestamp is less than the end time, so we only do this check if it's an active incentive. And so that means that, okay, this doesn't always, so for the current incentive key, it does have to come from the LP staker. This has to be somebody withdrawing their token. But for past, that's right, for past incentive keys, we don't have to do this. And you would increment these rewards. But okay, we're doing this totally outside of that system. And so then these have been incremented and they're ready to go to anybody. I don't even have to own this token. Is that right? Yeah, I don't even have to be the person that ultimately owns this token. And I definitely don't have to be the LP staker. I can get the rewards for that person shifted into this bucket, and we're not going to immediately zero this out and account for it for the right person. So that means what I could do is, as soon as one of the incentive key periods ends, you could have some sort of like MEV bot that comes in, unstakes all the tokens for everybody else, and then you unstake yours, you get the whole bucket. Yeah, this gets incremented with all of the rewards. Nobody's interacted with this contract. And then what you do is you unstake. You unstake for that, and then ultimately you come here and you end up claiming the rewards. And this is perfect because even if that's too good, because even if let's say somebody else, one of the people comes along, one of the people that you unstaked for, they come along, they are just going about their business. They might have, I mean, obviously you could engineer it so that this wouldn't happen. They might have taken the rewards from you unwittingly, but now since you unstaked for them, they can't, because this liquidity is going to be zero. And so, yeah, they've immediately, as soon as you unstake for somebody, they lose all of their rewards. And then what you can do is you can come in and claim and take those from them. It will all get credited to your token. Beautiful. Yeah, and then you can easily withdraw these. It's credited to that token. Okay, I pass one token. It's that token. I'm the owner. Oh, or I could just be, yeah, claiming all rewards straight up. That will do it for me. Yeah, we do this. Yeah, and then we get the reward and we get it. So that would be a high impact vulnerability from a small edge case here on Uniswap v3. So I think their accounting actually works aside from this small edge case. So this, really just this if statement enables it all. So that is the downside of adding interesting edge cases like this in your smart contracts when you want people to build on top of them. Okay, so I think that's probably a wonderful place to end things off here. I think that's pretty fleshed out. We'll have to see if that is indeed how it works. I'll probably do a POC off camera. But in the next episode, I think that's going to be our last episode in this live audit series. We're going to continue to dig into some of these leads that we have here, see if we can end up making anything out of any of these other interesting notes that we have, and yeah, continue to pull threads and sort of mess with things and see if we can get unexpected results in the system. All right, so that's all I have for this time. I'll see you in the next one.